Dijkstra's algorithm. This algorithm is to find shortest path between a source vertex and a destination vertex. From the figure we can see that A, B, C, D, F are the vertices. A line connecting any two vertices is known as an edge. Value given to an edge is known as a cost or weight to that edge. If there are more than one line connecting any two vertices, then it is known as parallel edges. If there is an edge connecting one vertex to that itself, it is known as a loop. Next, we can see that find shortest distance from the vertex A to vertex F using Dijkstra's algorithm for the above figure. Now we can see the steps involved in the algorithm. First, remove all loops. Step 2, remove all parallel edges with highest cost or weight. Step 3, create weighted matrix table. For that, set the value 0 to the source vertex and infinite to the remaining vertices. Next, mark the smallest unmarked value and mark that vertex. Next, find those vertices which are directly connected with the marked vertex and update all. Next, for all vertices, repeat 2 and 3. Update value formula is no destination value equal to minimum of all destination value, comma, marked value plus edge weight. After removing parallel edges and loops, the figure becomes like this. Now we have to form a weighted matrix table. For that, write all the vertices A, B, C, D, E, F as shown here. Next, put the value 0 to the starting vertex A and infinite to all other vertices. Next, look at the smallest value in this row. It is 0. Mark that value. Then mark that vertex A here. Now, look at the edges which are directly connected to this vertex A. This vertex A is connected to vertex B, directly connected to B, D and E. So now we have to update that vertices. We have to update this B, then D and E. For that, use the formula. This is the updation formula. New destination value equal to minimum of all destination value, comma, marked value plus edge weight. For that, we can see that, look at this vertex B. Then its value becomes, no destination value becomes minimum of its old value is infinity, comma, marked value is the 0 plus the edge weight connecting A to B. This is known as the edge weight. Edge weight is 2. So it becomes minimum of infinity, comma 2, that equal to 2. So put that value 2 here. Then next we have to update next vertex D. For that, similar way, minimum of this all destination value, that is infinity, comma, then the marked value is 0 plus the value to A to D is 3. So the answer becomes 3. Okay, write that value here. Then next we have to update next vertex E. Similarly we can write minimum of old value is infinity, 0, marked value is 0, plus edge weight is 2. The answer becomes 2. So update the new values to B, D and E. Then for all other vertices write the previous value. Okay, infinity, here infinity. Now look at this second row. Here the minimum value is 2, which corresponds to the vertex B or E. You can choose arbitrarily. So mark this value 2 for the vertex B. Then write the corresponding marked vertex left side here. Next look at the figure. Then now see the vertices which are directly connected to B. That is, B is connected to C, it is connected to D and is connected to A. A is already we have marked, so don't take it again. Then that means we have to update the vertex C and D. Then mark that is we have to update this vertex C and vertex D. So the new values we can calculate. For that, minimum of the old value, old destination value. Okay, old destination value is infinity, comma. Then marked value in that row is 2 plus edge weight. B is connected to C, the edge weight is 2. So minimum is 4. Then mark this value corresponding to the vertex C. Next we have to update D. The minimum of the old destination value is corresponding to D is 3, comma. Then marked value is 2 plus the edge weight is 4. Then the minimum is 3. Then mark the values corresponding to vertex C and D. They are 4 and 3 respectively here. Then all other values you write as such. So for E it is 2, for F it is infinity. Then after that look at the minimum value, that is 2, mark that value and mark the corresponding vertex E, left side. Then again repeat the procedure. For that look at the figure. Then the vertex E, that is directly connected to A and F. A already we have taken, so don't take it again. Then we have to update this vertex F. Now we have to update the vertex F. Then the new value for the vertex F is minimum of old destination value. Old value is infinity. Then the marked value is 2 plus then is 3 is the edge weight, so min 5. Then put the value 5 corresponding to the vertex F. Then mark the value for all the remaining vertices. Okay. For the corresponding to the vertex, write 4 as such. Then look at that row. So for C it is 4, for D it is 3. Okay. Then for F it is 5. Then in this row, look at the minimum. Minimum is 3, that corresponding to the vertex D. Then write that vertex D outside the left side of the table. Then again look at the figure D. In the figure, look at the vertex D. D is directly connected to A, F, C and B. Then we have already taken A, B. That means we have to update C and F. Then update the values C and F. Then repeat this procedure. We'll get a table like this. Then this marked value shows that the minimum distance from A to A is 0. Minimum distance from B to B is 2. Minimum distance from E to E is 2. Minimum distance from D to D is 3. Or it shows that the minimum distance from A to A is 0. Minimum distance from B to B, or minimum distance from A to B. A to B is 2. Okay. Then minimum distance from A to E. A to E is 2. Minimum distance. So we are taking the starting vertex as A. So based on this vertex we can write from A, the minimum values are from A to A 0, A to B is 2, A to E is 2, A to D is 3. From the figure we can see that A to C is 4, A to F is 5. That is the shortest distance from the starting vertex A to the vertex B equal to 5. Next we have to find the shortest path. This is the shortest distance. Shortest distance from the starting vertex A to the vertex F is 5. Next we have to find the path, shortest path from A to F. For finding the shortest path, we can see a method. For that, set the pointer from this vertex. Okay, by backtracking we will get the shortest path. That is, for that, starting from the end vertex, that is F, place the pointer here, then move this pointer upwards. If there is no change, again move upward. There is no change, then again move upwards. So here comes the change. Then next move the pointer to the left side. Then in that row, this, look at this, the minimum is 2. Stop the pointer there. Then the corresponding vertex is E. So we can mark. So we start from F. Then the pointer stop in F. Next take this pointer upwards. If there is no change, then again move in that direction upward. So here it becomes infinity, so there is a change. Then move this pointer left side and look at the minimum value. Minimum value is 0. Then that corresponding to the vertex A. So this will be our shortest path. Our shortest path is from backwards F to E to A, or from A to E, then E to F. A to E, we can see that this is 2. From E to F, it is 3. So shortest distance becomes 5. So shortest path is A to E, E to F. Shortest distance is 5.